Now let's talk about other TQM tools. The first one is check sheets. A check sheet is any kind of form that's designed for recording data. Let's take an example. Mary Beth, the manager of an apartment complex, feels overwhelmed by the number of complaints she's receiving. Below is the check sheet she has kept for the past 4 weeks. So here are the categories for the complaints: parking, pool, tenant issues, and plumbing. Each week, she's recording how many complaints she received in each of these categories. By looking at this check sheet, can you identify the area that needs improvement? Okay. Why? Because we can see that she's receiving more and more complaints in this category. The next one is the scatter diagram. A scatter diagram is a plot of two variables showing whether they're related or not. On the x-axis is the independent variable. The independent variable affects the y value. On the y-axis, we have the dependent variable, and the y value depends on the x value. Let's take an example. Suppose you're working as a head nurse in a hospital. You're managing all the nurses, and recently you're getting more and more complaints from your patients. You want to find out why you're getting more complaints. You notice that recently you had more nurses who called in sick and who are absent. And you think this could be one of the reasons. So you need some evidence. You want to create a scatter diagram. Now, which one should be on the x-axis? And which one should be on the y-axis? Typically, the cause of the problem is on the x-axis and the effect of the problem is on the y-axis. Y depends on x. So you think the number of complaints depends on the number of nurses who called in sick. So Y is the number of complaints you received, and X is the number of nurses who called in sick. Now, once you have the scatter diagram, you can use it to find the relationship between X and Y. For example, if your scatter diagram shows a trend that's going up like this, that means there is a positive relationship between X and Y. In other words, X and Y move in the same direction. If one goes up, the other goes up. If one goes down, the other goes down. So can you think of two variables that have a positive relationship? How about this? X is the number of hours you study for a test, and Y is the score you get from the test. The more you study, the better score you get. Next, your scatter diagram can show a trend that's going down like this, then there is a negative relationship between X and Y. If one goes up, the other goes down. If one goes down, the other goes up. They move in the opposite direction. Can you think of two variables that have a negative relationship? How about this? X is the supply of a product and Y is the price of the product. The more supply you have, the lower price you get. And next, your scatter diagram can show a horizontal pattern like this. That means there is no apparent relationship between X and Y. Even if X takes different values, the Y value doesn't change a lot. So they are not related. Can you think of examples of two variables that have no apparent relationship? How about this? X can be the temperature in Europe and Y can be the economy in the United States. Now let's try an example. Boston Electric Generators has been getting many complaints from its major customer, Home Station, about the quality of its shipments of home generators. Daniel Smith, the plant manager, decides to collect information on defective shipments through a form she has asked his drivers to complete on arrival at customers' stores. The form for the first 279 shipments have been turned in. Develop a scatter diagram. What would you recommend to reduce the percentage of shipments with defects? So in the first week, you shipped 23 shipments. Of the 23 shipments, 5 of them were defective. So what's the percentage of shipments with defects? That's 5 out of 23, which is 0.22. So if you convert this into a percentage, it's 22%. And you have a similar information for the rest of the week. Now, on the other hand, you have the number of new hires. In the first week, you hired 1 person. And the number of terminations, 0 terminations in the first week, and the turnover, which is the sum of the number of new hires and terminations. And we have similar information in the rest of the week. And you're concerned about the percentage of shipments with defects. This percentage is increasing. And you want to find out the root cause of this problem, and you want to use a scatter diagram. So what should you put on the x-axis of this scatter diagram, and what should you put on the y-axis? You suspect that we are experiencing a higher percentage of shipments with defects because of the high turnover. So the turnover should be on the x-axis, and the percentage of shipments with defects should be on the y-axis. So let's draw the scatter diagram. The turnover, it's 1, 2, 3, 4, 5, 6, etc. And the y-axis is the percentage of shipments with defects. So it's 20%, 10%, 20%, 30%, etc. So when the turnover is 1, the percentage was 22, 1 and 22. And turnover 3, percentage 23, 3 and 23. Turnover 5, percentage is 25. And the turnover 6 and percentage is 30. So you will see something like this. This is the scatter diagram of your data set. Is there a positive relationship between the two? Yes. As the turnover goes up, the percentage of shipments with defects goes up. Now, you can also create a scatter diagram using Excel. So let me show you how to do this in Excel. So in your Excel, you have the X values and the Y values, and you can select the data set and go to Insert. And click on this icon that looks like a scatter diagram, and Excel will give you the scatter diagram. Okay, now the next topic is cause and effect diagrams. A cause and effect diagram is a diagram that relates a performance problem to its potential causes. It's also called a fishbone diagram, and it looks like a fish. This is the typical structure of the cause and effect diagram. On the head of the fish, you write down the problem you have, and you draw the backbone of the fish, and you draw these branches. And each branch represents a category. You have a category for materials, you have a category for methods, manpower, and machinery. And we're going to list all the possible causes of the problem in each category. And these are called 4Ms. So let's take an example. The operations manager for Checkerboard Airlines at Port Columbus International Airport noticed an increase in the number of delayed flight departures. Draw a fishbone diagram to determine the root cause of the problem of delayed flight departures. So we're going to draw the head of the fishbone diagram, our problem, delayed flight departures. I'm going to draw the backbone and draw the 4Ms, machinery, manpower, materials, and methods. And we're going to think of all the possible causes of our problem, and we're going to list them under these categories. So, what can be the reason for delayed flight departures? Is there any mechanical failures? Mechanical failures, where does it belong? Machinery, right? Mechanical failures. Now, how about this? Are the cabin cleaners late? So where does it belong? Manpower, late cabin cleaners. How about this? Are the cabin crew members late? Where does it belong? Here, manpower, late cabin crew. Is the check-in procedure delayed? Delayed check-in procedure. Where does it belong? Method, right? Delayed check-in. Or are we waiting for late passengers? Late passengers. Or is the fuel being late? Late fuel. Where does it belong? Material. Now, is the food service being late? Late food services, it belongs to materials. Late food service. So how about this? Is there any weather problems? Weather doesn't belong to any of these. So you can create another category, other, and then list weather. Or are there any delays in the air traffic? Air traffic doesn't belong to the 4Ms, so you can list it under other. Air traffic delays. So this is the fish diagram.